We took one plant who was producing several gigawatts in the south, and over a couple scans, we were able to take them from 12 unplanned outages to 0 unplanned outages after utilizing our product.
Ed, coffee, tea, or something else? What fuels your mornings?
Black cold brew, pretty much every day.
The strong stuff.
That's right. Yeah, my wife has been recently trying to get me into matcha lattes. That's her go-to choice, and maybe it's been good. I haven't really fully adopted, but I've definitely been having a few of those as well recently.
Yeah. I find they're better later in the day, like with black coffee, just jumpstart the system. And then when you need a separate pick me up, those are nice. When you were a kid, what did you think you'd do when you grew up?
Yeah, I was spoiled with two parents who were engineers. My mom actually just retired after 40 years working as a systems lead engineer for the Department of Defense, and my dad's
Wow.
been doing computer smart device design for helicopters and more recently autonomous UAV. So it was kind of in the blood from the beginning to maybe be an engineer. I rebelled against that for a little while. Maybe thought I was going to go into chemistry or something in the biomedical space, but eventually kind of tripped into doing some robotics, high school robotics, that brought me into like really enjoying and learning kind of what my parents got to do on a day-to-day basis. And so yeah, I guess it was kind of an early onset for me. If I was a little better at baseball, maybe a professional baseball player, but otherwise I think the inevitable of being an engineer and building something was something that I've always aspired to do.
Sure, it was in your blood. Yeah. And congrats to your mom. That's huge, huge milestone as
Yeah,
well.
yeah, very happy for her. We just had a retirement party and honored her. It was really special.
Awesome. What's one technology that you can't live without?
Wow. I mean, the simple answers are probably our iPhones and our laptops right at the moment. Constantly have them on me, but maybe a technology that I'm using on those systems right now. I've really been enjoying the utilization of Obsidian, which is a note-taking application. Lets you move a lot of your notes into Markdown and create a lot of kind of a context map of all the notes that you're taking. And you throw some Claude agents on top of that, some skills in there, and you kind of start to create new insights for yourself along all of the different things you're working on. And it's been really effective for me recently. There's some pretty cool YouTube videos out there. I don't think I can separate myself from that right at the moment because it's really driving some new thought paradigms for myself.
Amazing. Yeah, I have to look into all of that because I think when you're leading so many different teams or functions or projects, initiatives, like having somewhere to collate all of that and get a different perspective on it, or maybe unearthing stuff that you didn't even think about must be so powerful. Man, I could. It's almost daunting if you haven't started doing something like that to go and start the research to think how you can adopt it. But yeah,
Yeah,
I think the
yeah.
sooner the
I
better.
mean, yeah. It's tough to get started at times, or kind of changing maybe the tools that you were using, but quite frankly, a lot of these tools are making it even easier to connect maybe some of your historical context notes, one-on-one notes, etc., and port them into these tools that like Obsidian that create this knowledge graph for yourself. You don't just have to have knowledge graphs for business. You can create a personal knowledge graph, and it's quite powerful because you can cut and filter and search through that in very unique ways, and it's definitely connected a couple topics for me, or brought insights out that maybe I was noodling on but didn't always understand all of the connections between. So
Yeah,
it's powerful.
yeah, yeah. I can only imagine. Last one. If you could fast forward 10 years and see one impact that your work has made, what do you want that to be?
Yeah, that's that's a great question. It's a doozy. I Yeah, I have been for the last 10 years obsessed with this idea that Jake Lucerarian and Troy Demmer, our co-founders at Gecko, really inspired me to think about, which is the health of our built world. There is just so much um, thought going into and money and resources going into the technologies of tomorrow, which is obviously very important, but we rely on a very fragile set of infrastructure, not just domestically, but across the world, both inside of power and oil and gas, but also inside of some of our manufacturing industrial bases and chip and supply. And we plan to utilize and we are extending the lives of those assets quite frequently. And if I could have any impact or contribute to improving the health of those assets, the production value, the lifespan, the sustainability of those things, and the future built world, I will. I'll feel like my motivations and fulfillment there were really really high. So those are the things that I'm been thinking about for a decade now, and will continue to probably think about for the next decade.
Well, you're in the right place, clearly. Welcome to Machine Minds, everyone. I'm your host, Greg Terusian, founder of Samson Rose, your robotics talent search partner. And on today's episode, I'm joined by Ed Bryner, Chief Technology Officer at Gecko Robotics. Thanks for being on the show today, Ed.
Absolutely. Thanks for having me, Greg.
My pleasure. Let's jump into it. So let's go back, start at the beginning. You kind of gave us a glimpse about that with your parents being in engineering. It was kind of like embedded in you. But what you mentioned, the college, or was the school, technology and robotics, was it a program or a club or whatever? What kind of sparked your interest in that off your own accord, outside
Yeah,
of like family pushing you into it?
yeah. At that time, it was Vex Robotics. We actually at my high school, Calvert High School in Maryland, did not have a robotics team. My younger sister, had actually started a first Lego League robotics team in middle school. So she got into robotics, a little before me. Started that team as she moved in. She's 4 years younger than me. She moved into high school as a freshman. She was like, I'm starting a high school robotics team. And I was a senior at that time. And I was, that was the time where I was like kind of figuring out exactly picking the school that I wanted to go to, picking the career journey I wanted to really start on. And she asked me to join her team as a senior as she was starting that team. And it really just started to kind of influence a passion for robotics. That very first year, we actually made it to Worlds. We were a scrappy little team with a very small budget in our very first year. Made it to Worlds. We got to interact with a bunch of other international teams. Made it to the finals in our region, and that really just kind of like made me realize just how big this world of robotics was starting to become. I was kind of in just a small town, and not realizing just kind of the breadth of like how many people were passionate about solving unique problems in this like electrical and software domain. And it really sparked just a really rapid, really deep dive into all things like right at that software hardware boundary was what I found to be like a really special place that I really enjoyed, and ended up going into school for electrical and computer engineering. I kind of wanted to get the best of both of those things. And yeah, and that kind of led me into where I am today.
Awesome. That's pretty cool that it was your younger sister starting that team
Yeah,
as well.
yeah, I really got to give it to my family.
Yeah.
I was highly, I really enjoyed chemistry too. I had some really amazing, STEM type teachers at that time,
Mm.
and chemistry was one of the classes I really enjoyed, and I thought that that was going to be something that I might sink into. But as I learned a little bit more about the career paths there, it was a little tougher and a little more academic, and I really wanted to not have an academic career. I wanted to, I really actually enjoy applied engineering. That's maybe something we'll talk a little bit about today. I really enjoy building at the edge and building and testing in an applied way. Yeah.
Awesome. Yeah, I want to dive into all of that. And obviously, throughout this path, you've eventually stepped into the CTO role. When did you realize? Because obviously, you didn't start in leadership or management, you have to work your way up. But is there a point in your career that you realized that you enjoyed leading technical organizations as much as building the tech itself? Or is it something you kind of fell into?
Yeah, it's I don't know. I think it was something that I was told early on in my career. I had some kind of personality strengths in cared a lot about how we thought about the people working with our technology, the people actually building our technology. It was something that technology is only as good as how it interacts with us as humans. That human interface is really important for me. And so, like, yeah, being able to connect with humans was always something that I, as an engineer, maybe you hear a lot about a lot of engineers wanting to sit and have headphones on all day. I was maybe an engineer who wanted to talk through a lot of different things because it's just how my mind worked. Over time, I learned how people work, how people are motivated, what they're fulfilled by, and how to motivate them. I came from a background of doing a lot of sports, as I mentioned, being a baseball player as well, and so I knew what it meant to be a leader of people, and also what it meant to build technology. After college and going and get my master's, I did anti-submarine warfare for the government. I had some I got to see some really amazing leaders working through those organizations, and some of the greatest leaders in the world come out of our military. I was a civilian on the civilian side, but I got to see what great leadership looked like there before I decided to go on a more entrepreneurial journey. And yeah, so I allowed, or learned from many of the greats, and tried to apply it in my own unique ways.
Love that. Just on that, you just sparked something that's been a pain point, I think, in hiring in general, especially for companies that aren't aware of or don't understand skill sets and experience from the military. And when people are going from the service to civilian population or trying to go into the commercial world, right? That the translation of what they've done, because a lot of it is very similar, but they maybe have different terminology, phrasing, like structure. And I always feel for that because I don't understand it fully, but I placed people and know people that have made that transition. It's like if you've got a leader or a founder who understands it and how they can utilize that experience and those people, you unearth such amazing talent. To your point, the leadership that you get and the camaraderie and the drive is
Yeah,
unique.
yeah, the mission orientation, especially, right?
Yeah.
The thought that, like, impact and mission really matters more than the day-to-day task, or the kind of the input output paradigm is, like, they are so mission oriented, so mission focused. There's a lot that we can learn in the commercial sectors from our military leaders. We at Gecko, just to say it, and to connect, what you're putting there, is we've hired several folks out of both the DoD. We're a dual use company, and we build for the Navy and the Air Force. And we've hired some really amazing folks out of, and subject matter experts that are leading various parts of our organization today. And yeah, we couldn't be doing it without them. That transition was hard. We've had to help them through that just as much as they've helped us to understand how to build and ultimately impact the DoD as well, because that's not an easy thing as a startup as well.
Yeah, for sure. Well, let's dive more into Gecko. So, for our listeners who may not know who Gecko Robotics is yet, how do you explain what the company does and your mission?
Yeah, we are a company who is building really rich health data around our built world. And we utilize that data in order to affect maintenance, reliability, production, and ultimately optimization of some of our most core infrastructure assets. So when I say that, you think of power plants, oil and gas refineries, military aircraft carriers. These are all assets that our robotic systems ultimately deploy onto, do digital health scans at a fidelity that's really never been done before, and generally is done by somebody who is put at height, at risk on scaffolding or on ropes. We ultimately build a suite of robotic systems that can climb, fly, swim around these critical assets, digitize a representative understanding of that asset over multiple times in its life cycle, and then can predict and project where and how we can better utilize that asset. You can think of it very similar to the electronic health records that each of our different doctors have on us as humans. We build a lot of the same scanning, diagnostic, and prognostic type technologies for our built world.
Powerful. Okay. Awesome. And I've followed, you mentioned the founders earlier. I've followed Jake for a number of years. And you might be able to tell me, I don't actually know the answer, but was there a different problem that the founders were trying to solve when they first started the company, or has it always been there? Because companies obviously they pivot along the way
Yeah,
and
yeah, yeah.
product changes. I'm just curious if that was the case here.
Yeah, no, it's a really awesome story. I mean, Jake, founded the company and took it into Y Combinator shortly after starting this in his college dorm room. He
Mm,
was introduced to a power plant out near his college, Grove City College, and the power plant manager was kind of doing a tour and telling these Grove City engineers about the complications of running this power plant, which was actually offline when they were there. And Jake started asking some of the foundational questions around, well, why isn't this power plant running? Why isn't it producing energy? And through those questions, he actually started to find out that the facility was going through several unplanned outages because of the reliability of the boiler tubes. And he also found out that not more than a year or two prior, there was a health and risk incident for somebody who was actually taking ultrasound scans at height at that particular facility. And so when he started to learn a little bit about how they were collecting this data, how they were ultimately using this data and why they needed this data in order to keep the plant running, he started to ideate on this wall climbing robot that could climb the tubes, take the person out of the at-risk height situations, and this is what our first Toka product ultimately was a wall climbing boiler robot for the power industry, and ultimately started creating really high fidelity health scans that even that human, at height couldn't collect at the fidelity we were. And over time, we started to iterate that, and we've taken several plants. One of our proudest moments was we took one plant who was producing several gigawatts in the south, and over a couple scans, and with our health reporting software and the repair planning tools that we had there, we were able to take them from 12 unplanned outages to 0 unplanned outages after utilizing our product. And that was a moment where we really started to realize we were onto something. And since then, we've really started to expand into our pivots have more so been into how do we increase the number of scanning modalities? How do we actually bring other data layers into our platform? how do we bring historical context into our platform? And we started to realize that our customers were most interested in this data foundation and context map that we were building for them, the health record of their facility, and how we could actually start to supplement that with things like operations data and their SME understanding. And this is what allowed us to then start building Cantilever, which is our where our customers actually interact with our system, and that is ultimately an AI powered platform to ultimately optimize many of the planning and reliability solutions that they use today.
Wow. Okay. So it sounds like a very close working relationship, feedback loop, and partnership with your customers has really helped like evolve and grow your product suite, the offerings, and things
Yes.
like that.
Yeah, we've from a very early day. We talked a little bit about applied engineering, forward deployed engineering, and become a very popular term. Uh,
Yeah.
but in our earliest days, our robotics engineers, and even today, it's not even our earliest days. Like today, our robotics and software engineers are deploying to these facilities. A lot of them, many people haven't even stepped foot onto or into many of the facilities we step on today, whether it's a submarine, an aircraft carrier, the bottom of a missile silo, inside of the boiler of a power plant. There's, these facilities are often secure, and we have to build the technology close to our customers. And so, yeah, we're a company that doesn't believe in just building in our labs. We have fantastic labs with many test assets. Greg, you should come out to our Pittsburgh office and see the accelerator that we've built there. But ultimately, it's what's even more important to us is deploying these systems often and learning the ground truth of how they're interacting with the physical world, and then ultimately how do our customers leverage this data. Early on, we used to produce standard our health report was Excel documents and PDFs on the very first iteration, because that's how our customer originally started to get this data from their original inspection companies. But once we started to realize that what really started to transform how they made decisions was actually providing them tooling on top of that data, that was when we really started to unlock that we were building a fully vertically integrated stack, from
Mhm.
robot to cloud.
Awesome. I will definitely take you up on that coming out there. Pittsburgh is way overdue a visit, so I'll let you know when I'm there. But yeah, I think it's so you're echoing a lot of what we talk about and just the truth here, right? Building in a vacuum, don't do that. You're going to come out to market, no one's going to want it. Not deploying into the real world and getting real world data, feedback, customer experience to find bugs, to tweak the offering, to refine it. Because, like you said, when you're building in the lab and building for demos or building just for like a cool video online, you're missing so much there. That's not going to allow you to scale commercially and have the impact that you hope to have with your product. So it's
Yeah.
great to hear it in a real example of a successful company.
Yeah. I would even say we're going to be making some really awesome announcements here in the short order following this podcast. But what I can say is we're lagging behind on like where a lot of other companies might be like very forward on some of their product marketing. We are putting all of our effort and investment in building really close to customers. So we haven't even shown many times, because we can't even get video equipment into the areas that our newest inventions are actually interacting with the world. We haven't even shown some of the coolest stuff that we're bringing to market here very soon, and we're really excited to launch some of those here really, really, really like imminently. So
Exciting. Okay, we'll talk about that offline. I'm curious, why has infrastructure inspection been such a difficult problem historically? I know you've mentioned some of like the scale and size and things
yeah,
like that, but
yeah. The I didn't even realize, just I think we I took for granted how uh, turning on a light switch and just expecting that power to power your home, and the grid and what that meant. I kind of took that for granted, but when you kind of like start to pull yourself out of the bubble and really understand exactly what's happening inside of these power facilities and manufacturing facilities, there's a lot to learn around the problems that they deal with on a day-to-day basis inside of production throughput and supply, and how the reliability of their equipment often drives the production value of that equipment as well. And we are relying on many assets that are being asked to extend their lives, while we try to figure out how to ultimately produce a more power dense solution, something like nuclear energy one day. And Gecko is actually at the forefront of even that nuclear energy paradigm. We have contracts where our robotic systems and software systems are helping to manufacture some of the nuclear reactors that are now being built, both for the Department of Defense, but some of those same components used for small modular nuclear reactors. So there's a lot of like really great interest there. But I think coming back to what you were asking, I really believe that the things that we are ultimately delivering and how we're delivering them is something that we're really passionate about.
And it seems robots in general are just like so ideally suited for these kind of challenges and this kind of use case as well.
The use case, and sorry, the thing that when we started to peel back, we started to realize just how many humans were still in the loop for collecting this data. How they were collecting it is like very labor intensive. They only were able to maybe collect a volume of data that wasn't machine scale and it wasn't localized. There was a lot of this data was transposed onto paper reports or downsampled in a way that we weren't actually capturing the raw data to actually improve the algorithms that created the displays for those humans to interpret the corrosion and cracking and damage mechanisms. And so really, as we kind of peeled back the layers all the way to like how those tools work for those humans that were collecting that data, we started to build the tools for the human that used to be up on. You'll hear Jake actually in some of his presentations and podcasts. He'll talk about Joe on the rope, right? This is to create a personification of like the people that we were building our first robots for, who were suspended via harness and put at risk. And when you're thinking about collecting health data hundreds of feet in the air, that level, there are special people. I am not one of them that feel safe in that environment, but there are others that that's a very high risk, high anxiety type moment, and you need to think about how you're collecting that data or where you're collecting it, and maybe you can't reach a particular spot based on the limitations of our bodies. And so we started to build these robotic tools that not just took that human out of that risk posture, but also was able to just collect the data continuously. And you add some LiDAR and camera on top of the ultrasound data that's scanning for cracking and corrosion. You start to fuse all of that information together and you start to localize it based on its closest weld line. You start to create 3D models of all of these assets. And then you start to actually have this physical, the physical representation of the world inside of this digital twin that we're building over time for these facilities. You start to like imagine all of the different workflows that we can start to build on top of that. How does the next human use that data to go and repair the crack or the corrosion that might ultimately take that asset out of its service life? How do we actually build predictive corrosion solutions once we understand that type of damage and why it shows up across many different asset types? You start to be able to answer questions that have never been answered before. And that's the power of what Gecko's been building, and those are the humans that are using it.
Crazy, isn't it? I think for the general public, because it was very eye-opening for me as well, just when you explain the problem, it's almost like, oh yeah, of course that makes sense. But what you can't comprehend is how it's firstly the size of some of these
Oh
facilities and these operations, right? Like, there's
yeah,
no way you can
yeah,
consistently monitor any part of it. And then outside that is how it's done today. Like you mentioned, as human in the loops, people walking around using their eyes if they're having a bad day or they're distracted, like they're not going to see it. They might miss a gauge to read or don't see a crack because it's out of eyesight or the sun is glaring on one side, anything like that. There's just so many areas for failure and misses. So when you have a solution like this, it's a no-brainer, right? And then, like you mentioned, all the extra added benefits that come along with that, and you start answering questions that couldn't be answered beforehand. It's huge.
yeah, and for people that haven't been able to answer it themselves, right? One of the things that we've really seen inside of the larger enterprise deals that we do is when you start to connect the financial team, the executive team that maybe isn't the ones walking around their facility on a day-to-day basis to the teams that are actually the unit owners, operators that are walking their facilities every single day, and you create this connective tissue, not just in terms of the charts and the PowerPoint slides, but actually being able to maybe even like almost Google Map style, or even better in some cases, drop yourself inside of the same asset on your computer screen that your owner operator is telling you needs a different repair tactic and justification for capital and or resources to go into that asset so that the entire enterprise succeeds. You start to connect those two people with these digital tools in a new way, a new paradigm, and it really provides a lot of context for why and how you might actually plan to do some of these things in a way that was very inefficient prior. Emails, tabular data, things that didn't actually represent the built world in a way that Gecko can.
Awesome. So you guys are obviously combining robotics, sensors, software, etc., a whole bunch of different technologies to inspect these large assets. Can you walk us through what the system actually looks like in the field? Because you mentioned there's like flying, swimming,
Yeah,
crawling,
yeah,
different types of embodiments of these robots, and then there's the AI and your software as well.
yeah. I'll give you. We could probably. Yeah, you'll have to come out to Pittsburgh and really see it.
Yeah.
But I can give you just like a little bit of context for really what we do. So yeah, there are times where we're integrating directly with a mobile platform that is off the shelf. We do build some of those mobile platforms ourselves. Our very first robot, the Toka series, was fully built in house. But today, many of our sensor payloads are really where we spend a lot of time. How do we time synchronize multiple health scan solutions and operational scan solutions? How do we collect all of this spatial intelligence data and connect it to the context of, let's say, a PNID or a serial number of the engineering drawings that ultimately originally designed that asset? Many of these assets, CAD was not a way that they were ultimately passing around the understanding and information of that physical asset. So we connect a lot of these health scans, these spatial scans, the lidar, the visual data that we collect. We layer all of that together. We time synchronize that. We have a lot of data collection intelligence software that enables us to collect, to move and collect the multimodal sensor, but also move in a couple of discrete ways, because not all of these assets are built the same. Some of them we have to fly around with a drone. Some of them we have to ultimately collect via the climbing robots, and others we have to swim around a ship hull as an example, or a ballast tank. And so these are assets that we ultimately want to collect while we want to collect this health data while the assets are running. Maybe that's another really key component of what we do. We really build these so that we can collect this health data continuously, and we can collect a lot more frequently. Not all the assets have to come down in order to collect this data. And that allows us to move our data not just into kind of the compliance, quality, reliability realm, but into the planning cycle more actively. If we can collect the data, the ship is a perfect example. If we can collect the data while it's sitting pier side or while it's on deployment, versus when the ship actually comes in for its maintenance overhaul, its availability, where the ship gets pulled out of the water and put into dry dock, we can actually compress the time if we understand the health of that asset in its entirety to start taking action as soon as it gets lifted out of the water, rather than once it gets lifted out of the water, do all this health scanning via humans climbing all over the vessel, come back, plan, figure out ultimately what supply shortages we have based on the understanding of that asset. We're able to collect all of that data continuously and have all that supply on hand, so that as soon as it gets lifted out of the water,
Yeah.
you're starting to take action. And that's a feeder for us. Like, we volumetrically understand, we spatially and volumetrically understand both the subsurface defects that we're finding, but where they are spatially on these assets. And because of that, we can actually start to, you can imagine where we can start to actually send this to actioning systems, whether that's a human or a robot. You can actually send the person directly to the point of care, and ultimately, solution that. The shortest cycle way I could describe this is in our manufacturing facilities. We are starting to fuse the fact that we can volumetrically scan a weld that was just laid. We can scan that. Robotic welder scans it, or sorry, robotic welder lays a weld. Our technology scans that same weld. We can understand and characterize a porosity versus a crack versus a lack of fusion. We can then send and fuse our data directly back to the original welding and grinding robot. It can go right back to the place that our system has ultimately identified and characterized, take action to fix that. But not just that, now take action to understand, why did that welder originally have a lack of fusion? What about the data that was inside of that welder, whether it was maybe a power cycle or ultimately something that wasn't controlled well inside of the environment, ultimately led to the quality issue the first time. And then we can start to create this repository that ultimately creates first time quality, because we can control for those elements more ruthlessly.
Awesome. I think a ship is such a great example, and I think a lot of people can probably understand like how, if you've ever been on a cruise, right? And you think about when these ships come into dock, like they charge them from the second they're there, to dock. But if you think about logistics and your goods being shipped across the world, any hour, days of downtime that takes, like these things cost so much money to run, to maintain, to operate, and even to just keep in port. So if you can accelerate some of that maintenance, that's a huge needle mover, right?
Yeah, means more production, means more efficiency. Yeah, it means more time of use in the Navy for their ships. They call this operational availability. What we're really trying to drive isn't just like how they think about maintenance, but how does this ultimately change their operational availability? And that's the piece that, going back to your question earlier on how we bring people in, that's the mission focus, right? Their leadership is really focused on asset availability, and we're helping to drive that by shortening the cycles that it sits inside of these dry docks.
Nice. What were some of the hardest engineering challenges you and your team had to solve to make these systems reliable in the real world and in these industrial environments?
Well, I'll tell you what, we're still working on that reliability term. That's something that we send these robots into really harsh environments, and I can tell you the folks that are deploying our robots are constantly asking for us to continue to increase the reliability, and this is something that I'm spending a good amount of cycles on how do we not just test at the edge for understanding where and why our customers are benefiting from our technology, or where they can benefit the most from our technology, but also how do we make these systems really operate in these dirty, dusty environments? Back when, we were kids, sure, the Mike Rowe series, the Dirty Jobs series was a really popular one. And that was something that, those are the types of environments that we're sending these robots into. And so the ability to make them and have them be ingress protected to the right ratings depending on the application that stack that we're building for, and being able to survive some of those harsh environments is a really, really tough challenge. We have a lot of our robotics engineers that are looking to constantly up level, stepwise up level our reliability, and takes a lot of testing, both in house and in the real world, in order to increase that. And over several iterations, we've gotten a bit better each time, and we're hoping to continue to increase that.
Awesome. I want to focus a little bit of time on team building, because obviously as a CTO, you cover all these different verticals. And as you mentioned, you're having to have these like perspectives and opinions and team and all of this stuff. It's a lot, when it's such a multifaceted team and org. But what does building a high performance technical team look like in a company like Gecko?
Yeah, it's challenging. You have to start with exceptional talent, finding exceptional talent that cares about your mission. This is something that, finding people that, don't want to just work on the latest fintech craze, the crypto arena, or ultimately want to work in social media. We're really looking for the type of engineers that are, want to dabble in this physical space, this real world. Physical AI is something that is talked about often, but what is special here is we have found engineers who are, not just remarkable in their technical competencies and skills, but also very passionate about how the physical world works. And so, finding folks that ultimately, want to learn and dabble in that, and kind of want to maybe learn inside of that domain, even if they haven't in the past. Maybe they worked on other critical health technologies. We actually have some folks that have transferred from health medical records and human health medical record type technologies. Those folks also, like, they come over and love this. And so, I think it's finding folks that really want to work in that intersection of the physical world and the digital world. Finding folks that want to change how our assets are ultimately maintained and sustained. Change how maybe the built world looks in the future, because we think our data will ultimately inform how and why we build certain certain assets in the future. And then I think the thing that I talk about often internally is orientation. How are you orienting yourself in order to shorten your cycles on understanding what problems you're trying to solve? If you're constantly just hearing from word of mouth, what you should ultimately doing, why not go to that first word of mouth? Like, go see it, feel it for yourself. Those are ultimately the ways to short cycle your learnings, and maybe instead of having to go through 4 or 5 iterations of your sensor package, if you had just gone and seen it for yourself the first time, you might, instead of reading it off of a requirements doc or off of a Jira ticket, you might have actually only had to iterate through that 1 or 2 times. And so that orientation is not just how you become a more efficient engineer, but it's also it's how you shorten the loop of like who you're impacting and why you're impacting them. Being able to see your latest iteration in the hands of the user is also like, we talk often about, like, what is the impact I'm having? I want you to feel that and see it in the physical world, because we're building such a physical product. And so, all of our engineers are encouraged to do that. I think it's created a culture of folks that really care about our end customer, and that work really hard together to shorten those learning loops.
Nice. Sounds like being inquisitive and being proactive, being really embedded in it, like you said, part of that, passionate about the problem. Because if you're not really going to go that extra step,
Yeah,
that
yeah.
want
I'll
to be
throw
out
out
there.
one other thing that I think is really cool because we build such a vertically integrated technology stack. We've really oriented our teams to be cross competency, vertically integrated as well. There's very few teams that are single competency teams at Gecko now, and the reason for that is because we want to ultimately have people maybe cross outside of the boundary of their you know uh, core training. So be an engineer, learn a bit about, if you're an electrical engineer, learn a little bit about how your boards are going to be mounted with your mechanical engineer that's sitting right next to you, and the software engineer that's ultimately going to be deriving maybe the sensor data that PCB is delivering. And so you put all three of those together with the subject matter expert who has looked at ultrasound data for his entire career. You put those three together or four people together, and you start to see a completely different level of innovation where
Yeah.
these systems start to come together. And that integration is something that we specialize in, not just in the product sense, but also in how we build our teams. And it allows engineers to dabble in, we have some software engineers that are working directly in the robotics field, and they started as cloud, web developers, and now they're helping to move these physical robots inside of the space so that you can see, just from your web, from your browser, exactly where and how this asset data was ultimately collected, and connecting those two engineers allows for engineers to dabble in some really cool technology that maybe they had not even gotten exposed to prior.
Very cool. That's a great thing to hear, because there's a lot of engineers, especially on the software side, that want to get into that, and
Yeah,
it's always hard to bridge that gap.
there's a lot of hardware engineers that want to get into software, and you look at all these, you look at the proliferation of all of these agentic coding assistants that are coming out now. It's never better than today to really be able to affect the full system across the entire ecosystem of what your team or company is building as an engineer. And so, these new tools are really allowing you to, I got to use them wisely. I will say that, but they
Yeah,
can let you start to affect a broader part of your architecture and ecosystem.
definitely. How do you balance speed and experimentation with reliability that's required for industrial infrastructure?
Yeah, this is a really tough balance. I think we've struggled with this. Like, frankly, this has been a challenge for us. How it comes with scale too. Like, as we started to scale up the organization, how do we know when the right time is to scale a particular sensor package or a particular software, or really productize something versus keeping it flexible so that you can like really experiment with the edge cases that might come really nearly close to the use of the original intent of the product or platform you had built. Um, there's a there's a funny quote out there from, it's not funny, there's a quote out there from Elon Musk. There's too many engineers working on scaling things that aren't actually driving scaling or creating reliable solutions around things that aren't actually impacting the world in the way that they are. Those are wasted cycles. So I think one of the things that we've learned over time is we don't want to scale too early. We actually, we had a Y Combinator ethos. Both our co-founders went through Y Combinator, and when we are building a net new product against a problem that our enterprise customers have brought to us based on the trust and contract vehicles that we have in place, we really start to think about really making it exceptional, make it great for one or two people versus just good for hundreds. And we really believe that we want to make sure that we're driving what we call value stories. How is this technology actually driving value for our end customer? Can we ultimately measure the ROI that it impacts before we start to really figure out how we're going to scale the technology? Does this technology impact the world before we scale it? And we spend a lot of cycles on that. We spend not just gut cycles, but a lot of our human brain cycles, capital, etc. But also, yeah, our financial capital on ultimately making sure that any new technology is doing that. And then from there, we will go through several iterations. It generally takes us, working through and doing things in production for a certain amount of time. We move out of this kind of like MVP to a POV, and our POV proof of value moves into kind of like a first tranche production run, and we'll probably still do that with our single customer that has ultimately brought that particular problem to us. And then from there, we'll start to look at the market because we've actually found value. So it's maybe a little bit different than how some other technology companies may derive their product roadmap, but it's something that has time and time again actually worked for us as a robotics company who's providing data to our customers.
Awesome. Yeah, I think it's a smart way of doing it for sure. And like you said, it is a tough balance, but
Yeah.
you got to do it
Knowing
right. Yeah.
the when question is always the challenge. When have we done enough to say, hey, this is worth scaling now? That, and maybe we do it. Those thresholds they maybe change depending on the program or customer that we're ultimately affecting.
Awesome. Well, look, we're almost at time. I do want to get your perspective here, or just I'm curious what excites you about the next 5 to 10 years in robotics and industrial automation in general,
Yeah.
from
Yeah.
your vantage point, right? You're embedded in this world, so I'm curious what
Yeah,
you're
man, we have been
hoping
for
to
a
see.
while. No,
Yeah.
it's been, I mean, the last several years, I mean, Gecko has been doing this for longer than some of the like other physical AI companies that are really gaining a lot of public attention right now, which is great. And obviously, we work in an arena that is maybe not inside of your residential household, folding laundry or making your personal consumer life better. But we are making your life better by really working and focusing on some of this, like the backbone of our industrial infrastructure and society. And that is something that we spend a ton of time on and we're really excited by. I think, just the amount of capital and attention that's being put into how do we navigate some of these different context graphs. We at Gecko are benefiting from. Many of our engineers, all of our engineers are picking up these agentic tools to be able to find efficiencies in their day to day, whether that's something as simple as automating the cleanup of their notes and email, all the way to actually doing rapid feature development on our roadmap. We're blowing through some of our experimentation roadmap faster than we ever have before, and it's allowing us to build not just new products and new features, but ultimately do more experimentation and build some transient code that we can just really just throw out and not regret it because it's much cheaper than it ever was prior. So I think the ability to experiment, the ability to really kind of, as an engineer, focus on the problem rather than maybe just your core trained competency is like a really exciting thing for engineers like myself and others at Gecko, where you get to dabble in many of the technical domains. And then, yeah, I'm just super excited about what those efficiencies unlock on the next types of problems that we get to solve. It's an ability to move and create efficiencies for humans that allow us to like move into the next domain of problem solving and creativity. I'm not one of the doomers that's like, oh, it's going to take my job. I'm actively looking for ways for me and my team to develop to create efficiency so that we can move into some of the problems that we've had to say no to, even though it is a problem to solve, right? There's just no shortage of things we could be working on to, yeah, make the next generation have an even better life than we have right now. I look back and just so much has changed since I was a little kid, maybe even before cell phones were a thing, watching watching kid shows on VHS. Now for my child, I'm flipping on YouTube and Netflix onto my smart TV, and the world's information is at my disposal. I can't wait to see kind of what that paradigm looks like 10, 20, 30, 50 years from now, hopefully.
Awesome. Awesome. Well, Ed, thank you so much for being on the show. It's been a pleasure.
Yeah.
Really enjoyed the conversation.
Yeah. Thanks, Greg. Really appreciate the time today.
My pleasure. How can our listeners learn more about you and Gecko Robotics and follow along for everything you're doing?
Yeah, feel free to connect. I'm on LinkedIn, Ed Bryner, and feel free to visit our website. We've got lots of postings for jobs right now at geckorobotics.com. And yeah, follow along because there's going to be some really cool news posted from our org really soon on national media. You'll probably see Jake and Troy and maybe myself, talking about some really cool things that are coming down the pipe with our customers.
Exciting. Can't wait to see what that is. And I look forward to staying in touch and visiting you guys when I'm in the area.
Awesome. I'm looking forward to it, Craig.
Thanks, Ed.